In this video, we will be discussing all about your page 20. So kindly prepare page 20. Now here's our target for this lesson. Calculate power for a mechanical system. So one more concept that we're going to learn in physics is about power. This is a word we hear a lot, and sometimes we relate it to superheroes because they have superpowers or super strengths. But in physics, when we say power, it means the rate of doing work. It measures how quickly work can be done. Using this formula, P is equal to W over T, wherein P means power, W means work, and T means time. As you notice, there is a triangle symbol in the formula that is actually called delta, meaning change. So we can also say P is equal to delta W over delta T, or power is equal to change in work over change in time. Now, one unit of power class is equal to 1 joules per second. And 1 joules per second is also equivalent to 1 watt. Now, watt is actually the SI unit for power, or the standard unit for power. To understand the concept of power better, let us have a situation. Let's say this two person here will carry these rocks upstairs, which is 4 meters above the ground. And let's say the rocks has a mass of 5 kilograms. Okay. Now in calculating the work done by the two person, we will just get the same answer. And that is actually the gravitational potential energy at that height. So we have W is equal to U, and it's equal to mgh, plugging the values, 5 kilograms of mass, 9.8 meters per second squared of acceleration due to gravity, and we have the height of 4 meters. Combining them, we get 196 kilogram meter squared per second squared. And remember that kilogram meter squared per second squared is equivalent to joules. So the final answer is 196 joules of work done by these two persons. Now class, though they have equal amount of work done, they could accomplish that task at different amount of time. Say this person 1 here on top finished it by 10 seconds, and the person 2 at the bottom finished it by 30 seconds. Now let us calculate the power of each person in performing the same amount of work. Let's start with the person 1. Of course, the work done is 196, and let's substitute the time, which is 10 seconds, and we get 19.6 joules per second, which is equivalent to 19.6 watts of power. For the second person, we have same amount of work, that's 196 joules. Substitute the time, which is 30 seconds, and we get 6.53 joules per second, which is actually equal to 6.53 watts. Sorry, that's 6.53. Okay, now in conclusion, person 1, which is on top here, is more powerful than person 2 because it finishes the work in a lesser amount of time. Okay, now for the exercises, we have problem number 1. Calculate and compare the mechanical power for the two different cranes above, referring to the concept notes. If the load is 700 kilogram and the height is 60 meters. So we have given, identify the given for the crane 1 and crane 2. So we have time for crane 1, which is 5 minutes, For crane 2, that's 1 minute. And then they have the same mass for the load and same height, 700 kilograms, height of 60 meters. Now we are looking for the power for crane 1 and crane 2. So we have P sub 1 and P sub 2. Okay, in the solution, okay, let's first find P sub 1. That's actually P sub 1, that's not P sub 2. Now remember that the formula for P, or for power, is P is equal to W over T. Now, here we need to get the value of work. So since we are not given the value for work, we need to solve for it. And how are we going to get the value for work? Remember that work is also equal to the energy. So here, the gravitational potential energy of the crane is what we are going to use for the value of work. We have mgh over t. Substitute the values. We have 700 kilograms, the acceleration due to gravity of 9.8 meters per second squared. We have the height of 60 meters, and the time. Okay, take note, do not use the time in terms of minutes. You must convert it to seconds first. So we have 5 minutes, that's equivalent to 300 seconds. Simplifying them, we will get 1,372 watts of power for crane 1. For crane 2, okay, same process. They just differ in the time. So here the time is 60 seconds. Combining, we will get 6,860 watts of power. In conclusion, which is more powerful? Obviously, it is the crane 2 because it has 6,860 watts of power, and since it finishes, or since the amount of time it takes is only 1 minute, which is lesser than on crane 2. Okay, for number 2 problem. A boy pushes his wooden cart with a horizontal force of 25 Newton through a distance of 12 meters. Find the amount of power he expended in moving the cart in 3 seconds. 3 seconds. So we have the force of 25 Newton, the distance of 12 meters, and the time of 3 seconds. And we are looking for the power. So for the solution, still, the formula for power is P is equal to W over T. And remember that work is equal to force times distance over, okay, we have over T. Substitute the values, 25 Newton of force, 12 meters of distance, and 3 seconds of time. Combining them, we'll get 300 Newton meter over 3 seconds, and the final answer is 100 watt of power. For last number, an engine has a power output of 1000 watts. Calculate the work done by the engine in half an hour. We have the given of 1000 watts of power, and we have half an hour. It's equivalent to 1800 seconds. So always remember that the time should be in terms of seconds. And we are looking for the work done here. Okay. Our formula for the work done, using the formula for power, if we are going to manipulate it, we will get W is equal to P times T. Substitute the values. Our power is 1000 watts and our time is 1800 seconds. And then the final answer is 1,800,000 joules of work. So that's it.